Okay, chapter 8 is on trigonometry. Turns out the first two sections are just introducing trigonometry. We don't do any calculus until 8.3 and 8.4. Okay, so what is trigonometry in the first place? So 8.1 is going to be our introduction. What's going on here? It's all about measuring uh, angles, it's all about rotation, it's all about the relationships between certain measurements as you rotate. We can study all kinds of things that have a cyclical nature. And so it's all based on, in kind of in one sense, it's based on the circle and rotating around. So let's start with that. So we can see here we're probably more familiar with this unit of measure here on the left. If I start on the x-axis and I'm going to think of revolving around counterclockwise until I get all the way back around to the x-axis, we've gone 360 degrees. So that is one type of unit that we can use to measure rotation. Okay, another one, and it's a little fuzzy on the screen. Maybe if I slide over a little bit clearer directly under the camera, maybe. This idea of radians, R-A-D-I-A-N-S, radians. So if I do that same measure, start on the x, go counterclockwise until I come back around, I'm not going to think of that as 360 degrees. Turns out that's exactly 2 pi radians going all the way around. You might think this is strange. What's up with this idea of radians? Well, it turns out radians are way more practical than degrees, although we're more familiar with degrees probably. Radians are the actual distance that you would travel around in a full circle. Like how the linear distance around that circle would be 2 pi, right? That's the circumference of a circle, is 2 pi times the radius. Okay, so it turns out radians really, really helpful. We're going to use both in this chapter. And here we can start to see the connection. 360 degrees is the same as 2 pi radians, and we abbreviate that RAD. Or even simpler, you might say 180 degrees is pi radians, just going halfway is 180 degrees or pi radians. Okay. So I wanted to start just by us getting familiar with radians and degrees. So hopefully this all just about fits. So I've got all these degree measures filled in to my table here. 0, 30, 45, 60, 90, 120, 150, and the last one is 180. And we're going to fill in the equivalent radian measure. Okay, so if we had 0 degrees, how many radians would that be? Well, 0 degrees, you're not rotating at all. That would also be 0 radians. Okay. How about 30 degrees? If you just go 30 degrees, just to, you know, like 1/3 of the way up to the vertical, which would be 90, right? Just a little bit. How many radians is that? Like, well, I don't know. If I just go up just this 1/3 of a little bit, you know, what's going to happen there? Well, I can look here. If 180 degrees equals pi, haven't I divided by 6? So this would be pi divided by 6 radians. Oh, so I'm 1/6 of the way from halfway around the circle. If halfway is pi, pi over 6, okay, maybe that's starting to make more sense. Hey, how about 45 degrees? So now I'm at a 45-degree angle. Well, I've divided that by 4. Wouldn't this be pi over 4 radians? Okay, how about 60 degrees? Well, I've divided by 3, pi over 3 radians. And maybe it's getting easier now. 90 degrees, dividing by 2, pi over 2 radians. Ooh, now this is getting interesting. 120 degrees. Let's see. Well, isn't that double 60? So let's double this. 2 pi over 3. 150 degrees. Oh, well, a couple ways I could think about it. I guess I could think of it as like adding 60 and 90. Or I could think of maybe if I go all the way back to 30, multiplying by 5. So it would be 5 pi over 6. And at that point, I've almost come all the way around. The next one is 180, and of course we know that that's pi, making it halfway around the circle. Okay, that's where I chose to stop. We're just getting familiar there, converting between the two, and just kind of really building our intuition for what the radians are doing. I want to mention this before we go on to really get into the trigonometry. We're going to set our angle, either if it's in radian, thought of as in degrees or in radians. We're typically going to use the variable theta. It's, if you haven't seen it before, it's like an O, but you've kind of done this swoosh coming back through. The Greek letter theta will represent an angle. Typically, we'll see x, sometimes for an angle, but more often than not, we use theta. Okay, so what do I have up next? We're going to define the trigonometric ratios. Later, we're going to think of these as functions, and we'll be able to do calculus with them. But for now, better to think of them as ratios. So imagine a right triangle. We're going to call that unknown angle theta, and we're going to label the legs as A and B and the hypotenuse as C. Of course, we all know the Pythagorean theorem, right? A squared plus B squared is C squared. We can kind of make a connection there. That's not where this is going, but kind of has a similar feel. Okay, so it turns out there are 6 trigonometric ratios. So I'm going to try and reveal only like one at a time here. That kind of works. Sin theta, we call it sine. The sine of theta is the ratio of A to C. Whatever that length is divided by that length there. A over C. Okay. Next up, trying not to reveal too much. Let me grab. Let's do this. Second piece of paper. Aha. Okay, next, cos theta. We call it the cosine of theta. That's going to be the length B divided by C, that ratio. The third trigonometric ratio is tan theta. We call it tangent of theta, A over B. Okay, so we're like every possible combination. Then, and I'll just show you all these at once, the other 3, to make a total of 6, are the reciprocals of those first 3. So where the sine of theta is A over C, now this one, and hopefully you can see that full name, it's called the cosecant of theta. We flip it over, it's C over A. Next up is secant theta, and its cosine flipped over, C over B. Finally, cotangent, COT theta, is B over A, the reciprocal of tangent. Okay, so we've got all these names. They're strange names. They're weird words. You probably, obviously we've heard the word tangent before, like the slope of a tangent line. It's the same word, but a completely different context means something completely different. when you see tangent here, don't think a tangent line. Think the trig ratio tangent. Totally, it's the same word, but totally different meaning. It's possible you heard the word secant before, the secant line. Well, same word. Maybe you've heard that, maybe not, in Calc 1. Totally different meaning here. So here we go with the 6 trigonometric ratios. Okay, so let's put this into practice with our first. Oh, wait a second. Actually, I don't have my first example just yet. Because we have so many of these trig ratios, it's easy to get them mixed up. So this turns out to be a helpful way to memorize sine theta, cosine theta, and tangent theta. When you look at the triangle, I wish this was all just on one nice whiteboard so we could point to it all at once instead of having this camera, but that's the way it goes. Maybe I can just get sine on there. So sine, if it's a over c, one way that people will memorize this is by thinking sine is opposite over hypotenuse. So my angle is here, the opposite side divided by the hypotenuse. And I've got SOH, sine is opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. So back up here, cosine, the adjacent side, if I'm looking at theta, the adjacent side is b divided by the hypotenuse. And that gives me CAH, cosine adjacent over hypotenuse. Finally, tangent, opposite over adjacent. If I'm looking at theta, the opposite side divided by the adjacent side, a over b. And people think of that as TOA, and so they remember this like saying SOHCAHTOA as if it was, one word or 3 words. SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And those are a great way to remember them. Then, of course, these are the reciprocals of each one. You just got to remember how they match up. Okay, I think we're at just about 15 minutes. I'm going to show this to you guys. We're going to put this into practice, do an example here, just to see if we know how these work and get some practice doing that. So I'll tell you what, I'm going to stop this video here. You guys go and fill in all 9 of these for this triangle. You've got 2 angles, alpha and beta, and we're to look at trig functions for, alpha, some with beta, for those numbers there. Let me invite you, pause the video right here, try these out. When we come back and do the next video, we'll do them together. So I'm going to stop this one here. I will see you at the next video in a couple minutes.